Welcome back to Confessions of a Time Monk. We're back in Bagno di Lucca at the Laszlo Institute of New Paradigm Research. And this month we're here for a conference on the new paradigm in holistic health and well-being. And this morning we had the privilege of actually listening to an introduction to the work of our guest who's kindly joined us. This is Carlos Ventura. And Carlos, Hi. You're based in Bologna at the VID Science. You founded the VID Science Lab.
Yes.
Can you just briefly give us a bit of information about the VID Science Lab?
Yeah. VID Art Science, it's an international movement of artists and scientists who are sharing a common journey. And we do believe that any art manifestation can deeply impact on the innermost dynamics of our biology. So that's music, that's theater, that's everything, painting. Whenever we look at these artistic networks with different eyes, which is VID, try to see things with different eyes.
This is going back to the etymology of VID.
VID is coming from the Latin imperative vide. Try to see things with different eyes. So have the courage to see things with different eyes. And sometimes what we call interdisciplinary is not enough. You may have a building with different scientists working in different fields. So the building is interdisciplinary, but the people inside, they don't even know what the other guys in the other room is doing.
So in general, their research is siloed.
Yes. So we need this meta or transdisciplinary endeavor, and we need to understand that whenever science discovers something really important, something really seminal, there is a kind of connection with some other realm. There is a kind of what we call intuition, which is just reconnecting ourselves with something which is invisible, and that will never be visible even with the most advanced techniques. So to me it's a kind of mistake saying, okay, we will find somewhere a new technique that will make visible something that we cannot actually see. This is absolutely true, but the invisible I'm talking about is a kind of signature, it's a kind of blueprint, it's a kind of information that it can appear through the change in forms, to the dynamic evolution of forms, which is formation, which is information. So something immaterial may connect the structure A with a different structure B, but you will never see the process of connection. You will see I'm starting from A and I'm reaching to B. But this leads to another level of understanding where this immaterial words need material event to get manifested up to something that we may define as a spiritual world, where there is no need anymore for something which is non-visible, which is immaterial to be manifested, something that stays beyond this kind of world. And whenever a scientist, even the most conventional scientist, is able to reconcile and therefore reconnecting herself or himself with this world, that for sure something new happens, some new seminal discovery comes out. I love with my students at the School of Medicine also to talk about the biographies of the major scientists. They were maybe working around in circle to a given problem for many years without a solution, only giving some academic insight on the major problem without really touching the inherent structure or information of the problem. But then suddenly, when they simply were out of their paradigm, out of their mental forms, the discovery came out, just like sudden
Can you give us a concrete example of one of the biographies of someone you'd have your students study and what that seminal moment was for that particular?
Let's say, for instance, when just a personal experience working on mechanical vibrations of cells, I was just thinking they were noise. They were just random motions. Until I met this wonderful scientist, James Gieseski, who has been working for many years. He's a pioneer of the studies with the atomic force microscope. And we have been working on this kind of nanomechanical signatures.
Nanomechanical signatures.
Yeah, we discovered that there is a meaning inside these motions. And whenever the cell is healthy or non-healthy, or whenever, let's say, a stem cell is going through a given pathway, which we call commitment or terminal differentiation, which are two very important steps in the transformation of non-differentiated cells into a mature cell of an adult individual, then we have this kind of signatures. And this is a dual phenomenon. That means that
so this is a signature. So define signature in this case. We're speaking about a sound signature, a visual signature.
I would say vibrational.
A vibrational signature.
Because there are some vibration that they have so low or so high in frequencies that the human ear cannot perceive them, but our cells do. They have all the systems and apparata for perceiving, detecting and deploying this vibrational signature.
And you shared with us an example of cells communicating with one another almost visually, but visually in the sense of vibrationally visually.
Yeah, for instance.
You were speaking about placing aluminum between.
Yeah, these were this fantastic experiment made by Günther Albert Böhler back in the early 90s, 1992. He published a wonderful paper in N.I.H, where he was working on cell cultures, and he was growing cells on the two opposite sides of this thin glass film. And on one side, he had what we call confluent cells, so they were very crowded. They were very close one to each other. On the other side, they were sparse. They were very rare, almost individual cells. Just consider that these experiments were carried out in the dark of the incubator where the cells are grown, and so there is no source for artificial light there. And despite this, these cells were orienting each other at defined angles. So it's like they were able to see each other.
So one side of the cell culture is orienting with the other side of the cell culture.
At defined precise angles. So then he deposited a very thin layer of a metallic film, nickel chrome, on the glass, in order that the two cell cultures were separated by this metallic film.
So they would have been separated both visually and in terms of vibrational frequency?
Yeah, but the problem, the major discovery was that this metallic film was able to prevent the phenomenon to occur. And then he said, he asked himself, it's just a matter of the thickness of the film or some more, say, subtle, elegant property. So he deposited a latex film, the same thickness, just a few angstrom, and the phenomenon still occurred.
The phenomena of the orientation
was still there.
Again.
Yeah, so it's not a thickness problem. The problem was that metallic film was somehow stopping a huge interval of frequencies of electromagnetic spectrum, which is light. This is light, what light is about. So lots of frequencies cannot pass through the metallic film, while the latex only absorbed, which means stopped, frequency outside the near infrared range. So the near infrared range frequencies could go through. And so he concluded that the cells were able to see each other with the form of an electromagnetic radiation that was emitted by the cells themselves and was falling within the near infrared range.
So let's step forward. And what's the implication of that in terms of your research now today, 30 years later?
Yes, this told me that cells are able to produce physical energies. They are able to orient themselves in space and time. And the next study, again by Günther Abel-Buller, found out that the cells were able to handle this form of electromagnetic radiation and use it to move along the tissue culture field and to aggregate. Now, aggregate is like a social moment in the cellular life, because from cellular aggregation, many other outcomes may appear, like differentiation, like growing, proliferation, and so on and so forth. Decisions like surviving to a hostile environment or go through programmed cell death. So the cellular aggregation is a very important moment. So I said to myself, okay, this is important because the cells produce physical energies. And then our subsequent studies demonstrated for the first time that if you apply an electromagnetic field to the cells, to the stem cells, you can drive their differentiating ability. You can modulate their ability to become any kind of mature cells.
So let's isolate this piece, because this is a very, very important statement.
Yeah.
So just say it again, very, very...
We first started with an electromagnetic field, which is commonly defined as extremely low frequency pulsed electromagnetic field. Technically was a field of 50 Hertz and 0.8 millitesla, which is basically the same magnetic field which is generated by a domestic electric power line. So by exposing mouse embryonic stem cells to this field, we turned on their differentiated ability in a very significant commitment to cardiogenesis. So basically they were transformed into spontaneously beating myocardial cells.
And you showed us pictures of this. So
Yeah.
I would just say to our audience, so we were seeing slides of differentiated cells that were in fact then pulsing as if they were a heart.
Just a micro heart in vitro. They were all together, they were synchronized, they were spontaneously contracting, beating.
The frequency that you were introducing would produce that particular effect? Or was that your research question?
No, we were just at the beginning interested in seeing what a magnetic field generated by a domestic electric power line was doing to the cell. And we only obtained a cardiac commitment and differentiation from the exposure to this field. Later on, we moved to another approach, which is using a frequency which is commonly used to connect through the internet, which is 2.4 gigahertz, which is the Wi-Fi frequency.
So this is the frequency that we're each exposed to every day in our normal environments.
Yeah, because so far internet is spreading all over around the world, public places, private homes, everywhere.
And how were you seeing the cells differentiate when they were exposed to this frequency?
There was not exposing simply to this frequency. We went through another kind of reasoning. So basically, we wanted to see what happens if we expose cells to a frequency which is commonly used. And the reason why we did this, because Wi-Fi energy is supposed to be
harmless.
Yes, safe, because the Wi-Fi card in the computer only emits this electromagnetic field at a radiated power of about 10 to 12 milliwatts. Now consider that as far as we are alive, we as warm bodies, we emit around 58 to 60 milliwatts. So it's a very weak emission, the one that is given by the Wi-Fi card in the computer. But this machine that we have been using, which was invented by Salvatore Rinaldi and Vania Fontani in Florence almost 20 years ago. And the name of the machine was Radio Electric Asymmetric Conveyor, REAC. was emitting this Wi-Fi energy only with a radiated power of 2 milliwatts. So the source of emission was very, very weak.
And we should say this machine was actually developed for what purpose initially?
Initially, it was developed to treat anxiety, psychological problems, postural defects, and treat pain. The peculiarity of this machine was that it was also sending a probe, an electrode probe, to the tissue that you want to treat. And one interesting thing is that this probe is not sending any electromagnetic field, but is just picking up the electric microcurrent that the tissue generates in response to the incoming magnetic field. So basically, it's not a conventional system to expose.
So it's not introducing something, it's essentially reading what's being produced within the body itself.
Absolutely. So the idea is there is a radiating antenna emitting a frequency at 2.4 gigahertz. This frequency will induce an electric field, a microelectric current inside the body. This was known since at least 40 years. But this induced microcurrent is not dispersed into the environment. It is picked up by this probe and sent back to the tissue that you would like to treat. So in this way, you will generate a flow of electric current without depth limits, up to the point that the tissue, which is in contact with the probe, will produce its own resultant microcurrent, like a microcurrent which is resulting from all these processes of radiating back and forth this induced microcurrent. Even this resultant microcurrent will be conveyed back to the tissue, and this resultant microcurrent that creates the therapeutic effects, not the incoming magnetic field. That is like saying that the treated tissue is mainly responding to an endogenous self-generated signal rather than to the incoming magnetic field.
So just pulling that out of the context of that and saying this in plain, really, really plain English, this is the body healing itself. Based on the introduction of information.
As I was saying this morning, we regenerate almost 70% of our cells in about 3 months. So we have inherent...
Regenerate 70% of our cells every 3 months.
This is not true for the heart, the brain, where this cell replacement is much, much slower, but it occurs anyway. But just to tell you that we have inherent capability for regeneration, for self-repair mechanisms. So a major issue which is currently accepted by scientists so far is so-called cell polarity. Even when we look at the histological pictures of the cell, we realize that they are not symmetric. So the shape of the cell is not symmetric. The apex of the cell is different from the basal part and the surrounding. They change according to the presence of other neighboring cells. Okay, so cells are structurally non-symmetric, they're asymmetric. I've shown this morning this sort of dance of the microtubuli, so they are oriented.
And people can find this online, actually.
So that's another example of intracellular polarization. The electric flows through the cells are polarized. So it's a kind of non-symmetric dynamic structuring of the cells at many interconnected levels, structural, anatomical, if you want, electrical, and at the level of nanomotions.
At the level of nanomotions.
So mechanical, vibrational patterning. Now, whenever you optimize, even at the electric level, the capability of cells to be polarized entities, then you will have an optimal situation for the cellular features to emerge. So if it is a cardiac cell, it will be a good cardiac cell. If it is any kind of cell, it will be a good kind of the cell. If it is a stem cell, it will be stem cells particularly capable of differentiating along multiple lineages, what we call pluripotency. So that means the ability of the cells to become almost everything. So we have tissue-resident stem cells. So we have stem cells residing in all body tissues. So instead of relying upon a kind of regenerative medicine where we need to harvest the stem cells, to grow the stem cells in vitro, to have lots of cells, and then transplant these cells back to a damaged.
Also not even sure that they're optimum in terms of what we're transplanting back.
Absolutely correct. Then we can target the stem cells where they are with the physical energy, because these physical energy have diffusive features. The sound, the mechanical vibration can go through the body. It can be attenuated, but you can handle these devices, what we call vibrational actuators, in such a way that you can target a specific region of the inside of your body. And at the same time, you can use an electromagnetic field to trigger these microcurrents and have an electric effect inside the body, which will drive cell polarity. In any case, or you can combine the two situations, mechanical motion, mechanical vibration, and electromagnetic triggering of this.
So you've spoken very technically about this, but essentially the long and short of this is that we're describing a completely new type of healing, which is non-invasive, much more efficacious.
Absolutely, and you can personalize the treatment because you can adjust the pause interval, the duration of the stimuli or the intensity according to the structure of the patient or the recipient body. But at the same time, these adjustments are so feasible, affordable, and rapid that you can have a kind of personalized medicine applied on a large scale basis.
So what's the timeline for this type of healing methodology to actually enter the mainstream?
We are already on the patients.
These are clinical trials at this point?
Dr. Rinaldi and Fontani, who are the owners of this REACT technology, they're already going to clinical trials in China, and as far as I'm aware of, also somewhere in Italy. And also from our side, we are now developing vibrational actuators. That means very, very flexible and portable devices that can afford delivery of these mechanical signatures of vibrations. We, as I've shown this morning, we can record the patterning of nanomechanical motions from cells that are going in towards a specific commitment. Let's say a human stem cell which is becoming cardiac, neural, skeletal muscle, vascular cell, or any kind of cells that will be part of an adult body. We can record this vibrational patterning as a signature of the specificity of the commitment. We can apply the signatures back to the patient, and in order to guide, to direct the differentiation properties of these cells, and not only the differentiation capabilities, but even the secretion of molecules that will somehow spread a message of self-repair inside the tissue. Because not only the stem cells are able to replace damaged cells by differentiating into a type of cells that have been lost throughout the damage of that tissue, but they can produce molecules that somehow act as a teacher for reprogramming the surviving stem cells in the same environment and making them able to retrieve capability for repair, for regeneration. So it's a kind of amplifying effect, which is not only differentiation of the cell, but what we call the paracrine effect. Paracrine the paracrine effect is a sort of endocrine effect at a very short
endocrine
range.
effect.
Yes.
An endocrine effect.
Yes.
Uh-huh. Carlos, if you needed to bring this and wrap this up, what would your core vision for 10 years from now, what that might look like in your field in terms of the application of this research?
Well, I foresee that we will have the possibility to take a glimpse on how our cells, our tissue express, as we said, signatures of their status and their ability to come up with decisions. We can decrease dramatically the threshold for self-healing. So without this self-healing mechanism, there will be no reason for any type of cure that we have invented. Even the most conventional, the most alternative kind of therapies, they all rely upon this ability that we have for inherent self-healing. So we will decrease this threshold dramatically. We will be able to detect also signatures on how our treated tissue are responding to the treatment, and maybe harvesting our other signatures of this regaining of function, and transform these signatures in something which we will be able to feed back to the patient in order to have more personalized medicine. That is, one thing is harvesting a signature from the cells in vitro. We know that it works in vivo as well, but then we want to harvest the signatures of how we are regaining function in the organs. We hypothesized that our tissues will not behave in the same way in the same patient, which we may have part of the tissue that will respond earlier and better than other parts that will exhibit a delayed response. So in the future, we will be able, in the future I mean in the next 2 or 3 years, we will be able to harvest signatures on how we are retrieving self-healing in the treated tissue, just to send to the same tissue back those signatures and help the initial treatment to be more efficacious and more personalized. So this will also be a way to have a kind of regenerative medicine which does not rely upon anymore on the transplantation of tissues or cells. And I foresee new devices that can deliver this kind of information to our body, and other devices that will be used not only for diagnostic purposes, but the diagnostic journey will also encompass the possibility to cooperate with the treatment. In other words, it's like saying that so far you take an NMR scan just for diagnostic purposes. We may harvest vibrational signatures for diagnostic purposes, but at the same time those signatures will tell us whether or not the tissue is healing, and we can take the healing signatures in order to enhance the recovery, the overall recovery of the tissue in that really particular patient.
Completely new paradigm in healing.
Yeah.
So, and that's part of the vision of this institute, is actually looking at new paradigms. Yeah. So I very much appreciate you sitting down with us and sharing your piece in this push toward the future.
Thank you so much. Thank you.
It's been really a pleasure.
Pleasure to me as well.
Thank you.
You're welcome.